number 8, part number 2, and the pages that are involved here are pages 25 to 27. This is really a section where you can go through. The textbook section does a very good job of explaining how this works. This goes back to the particle theory, the collision theory, and always answers the questions in our course that are entitled, What's Happening at the Molecular Level? Okay, so you're going to use your particle theory to explain all of these things, and here are the answers for that. So basically, it's a work your way through this lesson, work your way through these pages. And I think what we'll do for module number 9 is I'm just going to show you what the clock reaction looks like and get you to answer a question and then submit it. And in your answer, I'll just be talking about why does changing the concentration of a particular reactant affect the rate of reaction. Okay, and you're going to use the collision theory to explain that. So here we go. According to collision theory, the rate of a reaction is dependent on these two factors. Number of collisions per unit time. Okay, how many collisions can you make? If you increase the concentration, you're going to have more collisions. If you increase the surface area, you're going to have more collisions. More collisions, faster rate. The second thing is the fraction of those collisions that are successful. So yeah, that terminology is going to be important. It's exactly what it is, okay? And this has to do with correct collision geometry, all right? So if those particles can collide, if there are particles to collide to begin with, and if those particles collide with the correct collision geometry, then you're going to be able to increase the rate of a reaction, okay? So those are the factors that depend on it. One more thing is this part right here, one more factor. Minimum amount of energy required to meet the energy of activation. All right, so that's the collision theory basis for explaining what's happening to these molecules as they're reacting with one another, okay? And then there are some factors that affect the rate. So the next few pages, you're gonna follow through, and I've got lots of the answers already given for you, and you're gonna look at things like, what about the nature of the reactants, the type of the reactants to begin with, okay? What about the concentration of the reactants? And you already know that adding and changing all of these factors are things that are going to manipulate the rate of a reaction. So obviously temperature is going to be there. And then what about adding a catalyst, right? A biological catalyst like an enzyme, right? There's lots of reactions that can't take place without adding an enzyme. And in chemistry, it's very similar, all right? You can take hydrogen peroxide, add in a catalyst like yeast or potassium iodide, and you can get the breakdown of hydrogen peroxide very quickly. What does it do? How does it do that? It decreases the energy of activation required for the reactants to turn into products, right? So that's the elephant's toothpaste demo that somebody posted on the classroom from a previous module. So have a look at that, okay? That's your example of a catalyst. And surface area. We're going to get to surface area in one of the following modules. So for now, you're going to look at the first 4, but if you follow through your notes, make sure you're sort of highlighting the headers as you go along. It'll help with your explanation. Okay, good luck with that. And that's basically leading us almost to the end of our unit. So we're done most of the calculations, and now it's just about explaining what's happening at the molecular level. All right, good luck. See you next time.